Okay, here's our second problem. It's from review quiz number 1. This is number 8. We have a particle moving on this parabola y equals x squared. We know that it's moving along the x-coordinate at a constant rate of 3/2 units per second. We want the rate of change for the distance from the origin. So what this really comes down to is if we were to just quickly sketch out this y equals x squared plus 1, it's up 1, we have a parabola, right, that's been moved up 1. So no matter where we are on this parabola, we want to see how our distance to the origin is changing. Well, since they made it easy by going to the origin, because our distance from the origin will always be based on x, y, and there's our distance. So we can write that distance equals, and this is a Pythagorean theorem, square root x squared plus y squared. That will be our distance. That's an equation now that rates what we want and what we know. Well, we want the rate, so we want the derivative of that. So derivative of d terms of time. This is one of our related rates problems. Square root, we know that ends up being derivative is 1 over 2 square root x squared plus y squared. It's a chain rule, so times 2x dx dt plus 2y dy dt, right? Because it's a related rate. So 2x dx dt, 2y dt. Alright, so now we have our derivative, and that's what we want to find. And so it's really just plugging in at this point. So it also, in the problem, I didn't write this down, but it's actually given to us in the problem, that we're finding this at the point 1, 2. So I'm going to make all my x's 1, I'm going to make all my y's 2, dx dt they gave me, now I just need dy dt. So if I want dy dt, I go back and figure out what my y would be. And if I go back here, right, so I'll pull this down here, right? Here's an equation that relates y and x. So if I derive that, dy dx, I should probably do everything in terms of t since that's what I have up here. So dy dt equals 2x dx dt. 2, I know my x is at 1 now, and dx dt was 3/2. So 2 times 1 is 2, 2 times 1.5 is 3. So dy dt is now 3. So when I come back here and plug it in, let's see if I can get myself a little bit more room here. Hopefully this is still on the camera. So when I start plugging in, I've got 1 over, right, and I'm plugging into this one, the derivative of d. So 1 over 2, right, so now that's a square root of 1 squared plus 2 squared, so that's square root 5. Times, right, and this really, right, that little term really traveled together. So I don't know if I necessarily need that, but we're going to end up doing that first. So times 2x, my x is 1, dx dt, 3/2, plus 2, y is 2, dy dt we found was 3. So again, 2 times 1 is 2 times another half times a 3. 2 times 2 is 4. 4 and times 3, 12. So that's really going to be a 15. So I've got 15, right? 3 plus 12 times R1. 15 over 2 square root of 5. If I remember correctly, I don't have the answer sitting in front of me, the answer choices, but my guess is they rationalized the denominator. So we multiply both by square root of 5. And then one more simplification, cut them both by 5. So hopefully that all caught on video, and we will see you later.